Lesson 9.3 will be a little different in that I'm actually going to go through the quick check problems with you here in the video today, so you won't do those on your own. The reason being is I want you to understand today's lesson, and I want you to know what these things are, but we're not going to do a whole lot in terms of the test and quizzes and things with applying this lesson today. It's just something that I think is a little less important than some of the other things that we're covering, so we're not going to stress it as much. And what we're looking at today is rotation. And we can add this to the list of growing transformations that we've learned about. So we learned about translation, where we slide an object. We learned about reflection, where we reflect an object, whether it's across the x-axis or the y-axis or some other line. So that was our second transformation. And now the third one that we're going to learn about is third transformation is rotation. And this is where we take something and we rotate it about some sort of axis or vertex. So if we think about this point R, if we were to rotate about the point R, we could rotate that point and it wouldn't go anywhere, right? So the image of R is itself when R is the point that we're rotating about, right? Think about if we were to take a piece of string from R to V, and we were to take a pin and we were to put it through the piece of string on this end and tack it to a board or a piece of paper or something like that. We could then move V around a certain angle, so we could measure this angle, and that would be the angle that we rotated V around the point R. So whatever point is being stationary, is staying put, that's the point that you're rotating about, your point of rotation, and the angle that we rotate another point, so if we took V from here up to here, would be the measure of this angle in the middle here. So for any point V, it says RV prime, so the image of V is going to be equal to RV, the preimage of V, and we can see that here if we use the same string, right? We can just drag this string up here and we're going to have the same length. And the angle is going to be whatever angle we're saying. So we're rotating it x degrees. So that's going to be the angle from VRV. It says the center of a polygon is a point that is equidistant from the polygon's vertices. And so we'll see that a lot in some of the example problems. They'll have like a hexagon and they'll look at the center and they'll talk about rotating the polygon about the center of the polygon. So we'll see some examples with that, which is why they mention it here. So let's see some more examples. Here they're telling you how to do this using a protractor. Again, we're not going to focus on this. I'd like you to see it, but I'm not gonna actually make you guys do this in terms of using the protractor to draw a rotation. So what they want you to do is draw the image of triangle LOB under a 60 degree rotation about point C. So again, if we had this triangle on a piece of paper and we stuck a pin through that piece of paper at point C so that we could spin the paper around without L, O, and B changing, and with point C staying exactly where it is, that's what we're talking about. So this whole thing would just kind of travel up along here. So what they have you do is they have you draw a line from O to C, and then they have you measure 60 degrees and draw another line. So here's the line from O to C, and then they have you draw another line 60 degrees from that line, and there's our angle. And so if we're rotating point O about point C, we're going to rotate it around to here. So you would use the compass and you would trace out, you would mark this length, and then you would drag your compass along to where it crosses this point, and there's our new image of O. And we would do the same thing for L, right? So we would do a line from L, and then we would mark that same line around to 60 degrees, mark it here, and for B, and we would get our 3 points. Again, you're not going to have to do that on a quiz or a test or anything, but it is important for you to understand that just like when we reflected and we reflected each point, or when we translated and we translated each point, if we're rotating an image, you can rotate each point, so 60 degrees. 60 degrees around from there to there, 60 degrees around from there to there, and 60 degrees around for B from here to here. Okay, so let's take a look at another example. Now we're going to be rotating this image. They have a hexagon. And remember, we said the center is equidistant from the vertices. And they tell us that it's divided into 6 equilateral triangles. So that means the distance here is equal to the distance here, is equal to the distance here, right? Equilateral, all 3 sides are the same. So it says, name the image of B for a 240 degree rotation about M. So M's the center. So if we're rotating B around 240 degrees, let's think about this. If from B all the way around the circle back to B is 360 degrees, and how many triangles do we have here? We have 1, 2, 3, 4, 5, 6. So if from B to B there is 6 triangles, we can take 360 divided by 6 and come up with 60 degrees for the angle in the center here for each one. So each central angle measures 60 degrees. So if we're rotating 240 degrees, how many 60 degree angles do we have to add up to make 240? And the answer is 4. So if we were to go, here would be one 60 degree increment, then another 60 degrees would be 120, another 60 degrees would be 180, and another 60 degrees would be 240. So if we took B and rotated it around M, we would rotate that around 240 degrees, and so the image would actually lie 4 triangles away, right on top of, oh, they're going the other way. Look at that. Counterclockwise rotation. So I'm going the wrong way. We really want to come 240 degrees, 60, 120, 180, 240, around here to D. So I went the wrong way the first time. So we would rotate that point around right to D, going from B 240 degrees around here to D. All right, we can get rid of that. Now they want us to name the image of M for a 60 degree rotation about F. So again, if we look, the central angles are still going to be 60. Here we have AMF is a triangle. We know it's equilateral, so we know all 3 of the angles are going to be 60 within that triangle. And it says a 60 degree rotation of AMF about point F. So here's point F. If we're rotating that, that would take FM, which is this line here. If we went 180 degrees, it would superimpose FM onto FA. So if we took it 60 degrees counterclockwise, this line here would rotate 60 degrees that way, and it would end up on top of this line here, FA. Okay, so the point, in this case, if we took M and rotated it around, would be on top of point A, right? This point M would be on top of point A. So looking at the quick check, they want us to draw the image of LOB after a 50 degree rotation. So if we look, it's going to look something like this. Again, if you're rotating around point B will not change. But L is going to move 50 degrees counterclockwise, and O is going to move 50 degrees counterclockwise. So it's going to look something like that. Again, not something that you're really going to need to do, but you will need to realize that this whole image is going to swivel in this direction around this point B. Another one here, they give us a pentagon instead of a hexagon like they did before. So we get 5 congruent triangles. So now we've got 360 degrees going around, but there's only 5 angles. So if we do 360 degrees divided by 5, Alright, we can pull that up on our calculator. Here we go. So 360 degrees divided by 5 angles, we get 72. So each angle in there is going to be 72 degrees. So if we want to go 44 degrees around X, we're going to take T and we're going to go 1, 2 triangles, and we would be superimposed on top of point E, right? So 72 degrees from T to N, another 72 degrees from N to E. That's the kind of problem that you would be required to do. So you will need to know how to do this type of problem. The ones where you're drawing and you're just doing like free angles in here, that I'm not going to require you to do. But on a polygon like this, where we know the value of these angles and we're just rotating points on top of each other, this you should be able to do. Alright, 2 more examples. Maybe 2 more examples, and then we're done with the quick checks. We'll hit more quick checks and then we'll be done. So here again we're rotating. It says a regular 12-sided polygon can be formed by stacking congruent square sheets of paper rotated about the same center on top of each other. So they just take 3 stacks of paper and they rotate them so that the points are equal distant around each other. If each square has 4 points and there's 3 squares, that's 12 points, and they just evenly space them around the circle. So it says find the angle of rotation about M, so M is at the center, that maps W to B. Alright, that maps W to B. So now in this case, if it's 12-sided, again, if we look at 360 degrees and we divide that by 12, we get 30 degrees for each angle. So each vertex is going to be a 30-degree rotation about point M. So if we're trying to go from W to B, we need to go 1, 2, 3, 4, 5, 6, 7 vertices. So that means each vertex is 30-degree rotation. 7 of them, 7 times 30, we get 210 degrees. When we look at compositions, we can rotate once and then rotate again and combine those 2 rotations. Just like we did in translation, we can translate along the x-axis, then translate along the y-axis, or we can translate x and then x and add them together. So you can compose multiple transformations. In this case, they want to know the image of a quadrilateral for a composition of a 145-degree rotation and then a 215-degree rotation. So if we look both about the same point, if you do 145 then 215, that's a total of 360. So essentially the image will just be a complete rotation. So the image is going to be the same as the pre-image. Think of spinning in place 360 degrees. You end up right back where you started. So the pre-image and the image will actually be the same in that case. Alright, last 2 quick checks again. I'll go through these. It says in the figure from example 3, find the angle of rotation about M that maps B to K. So this time we're trying to go from B to K. But again, we need to go counterclockwise. So we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. Each one is 30 degrees. So now we're doing 9 times 30. And so we get our answer of 270. And then the last one, again, this is the kind that I'd like you to be able to identify and visualize, but I'm not going to ask you to draw these. It says draw the image of a kite for a composition rotation of 2 90-degree rotations about point K. So if we did one 90-degree rotation, it would rotate over to this area, right? 90 degrees over to here. Another 90-degree rotation, so that's 180 degrees total. We would rotate essentially just to the opposite side of where we are now. So it would look like this. Alright, that's going to be it for today. Again, we're going to work on practice tomorrow, practice 9.3, but we're not going to be doing the problems where we're actually going to be drawing the rotations, just more calculating rotations in polygons and other situations, identifying them. So you can look forward to that tomorrow.